Hello, Math 141. Find the exact value of the logarithmic expression. Let's start with something as simple as log base 2 of, say, 32. So here I can say that log base 2 of 32 equals to what? Okay, and since we are doing math, instead of writing what question mark, I'm going to go ahead and put x instead. And I know that 2 to the power of x must equal the argument of the logarithm equals 32. And I know that 2 to the power of x equals 2 to the power of 5. 2 times 2 times 2 times 2 times 2 is 32. And so now this follows that x equals 5. Because if the bases are the same, the powers must be the same. You could also, from the get-go, a shorter version would be when you had log base 2 of 32, just to go ahead and rewrite that as log base 2 of 2 to the power of 5. Cancel this, and the answer is 5. And I really have no preference. So the left-hand side is the logic. But after you get good at it, I just don't see any value of writing every step down. Okay, what if you had something as, say, log base 2, okay, of, say, 2. And if you tell yourself that, how do I deal with that? Well, same way. You can say log base 2 of 2 equals to what? In other words, log base 2 of 2 equals x. So 2 to the power of x equals 2. 2 to the power of x equals 2. So here, and I know 2 is the same as 2 to the power of 1. So x equals 1. Okay. Let's do one. This is what I wanted to tell you, that if you are doing like the log base 2 of 2 and you are doing this canceling, if there's nothing there, it doesn't mean a 0. You have a 1. So, please remember that. That's why I'm not very fond of the short version of simplifying in the very beginning until you get good at it. Suppose you had log base 5 of 1. All right, that's actually not bad, because this is the same as saying log base 5 of 1 equals to what? And 5 to the x equals 1. And I know x must equal 0 because 5 to the 0 equals 1. Let's do at least one that involves a fraction. Going to the next page, how about this? How about log base 3 of 1 over 27? Okay, same logic. I can say log base 3 of 1 over 27 equals x. 3 to the x equals 1 over 27. 3 to the x equals 1 over 3 cubed. 3 to the x equals 3 to the power of negative 3, and x equals negative 3. And let's say the shorter version, I could say log base 3 of 1 over 27, same as log base 3 of 1 over 3 cubed, same as log base 3 of 3 to the power of negative 3, and there it is, my negative 3. One last one, something involving something that you really don't, I don't think you see something like this very often at all, but how about something log base 9 of cube square root of 3. Sorry, log base 9 of square root of 3. How interesting. Okay, so this I can now say that log base 9 uh, of root 3 equals x. And so 9 to the power of x equals root 3. So 3 squared to the power of x equals 3 to the 1 half. And 3 to the 2x equals 3 to the 1 half. And since the bases are the same, now I have 2x 2x equals 1 half. And if I multiply both sides of this equation by 1 half, I get x equals 1/4. Okay. Now, this is one of those that the short version probably for most students would be counterproductive. And here's what I mean. If you say log base 9 of root 3, okay, so now you have to replace this, okay, you have to replace this with something involving 9. And so you can say log base 9 of 9 to the power of 1/4, okay, and cancel this. But but I think you need uh, a few days of practice before your mental arithmetic get there. Okay, but it's up to you. It doesn't matter to me. I hope you like these examples and let me know if you need more. Thank you.